Have you ever really thought about what goes on during a sleep study? It's so much more than just, watching someone sleep. It is a science of mind-blowing precision. Today, we are going to pull back the curtain and see exactly how sleep technologists capture this intricate electrical symphony that's happening inside the brain, all to unlock the secrets of our sleep. It's a whole world of precision, patterns, and patient care, and it all starts with one fundamental question that I'm sure you've probably wondered about.
But before we get into all the nitty-gritty, let's just tackle the big sci-fi question right away. I mean, come on, you look at all those wires hooked up to someone's head, and it is so easy to imagine a scene straight out of a movie. You gotta wonder, is that machine actually reading someone's mind?
And the answer is a big, fat no. Absolutely not. An EEG is not a mind reader. It's actually way more like an incredibly sensitive voltmeter. It has no idea what you're thinking, whether it's about your mortgage or what you're having for breakfast. All it does is measure the teeny-tiny electrical voltage changes that happen when millions and millions of your brain cells fire off together. A great way to think about it is like this. It's listening to the overall hum of a giant city, not eavesdropping on one specific phone call. The key concept here is something called derivation. All the machine is doing is comparing the signal from two different spots. If the electrical chatter is exactly the same in both spots, you get a flat line. But if it's different, well, that difference is what creates the beautiful, meaningful brainwaves we can actually analyze.
So here's the game plan for our journey today. We're going to start with what an EEG is actually doing. Then, we'll become brain cartographers, literally learning how to map the skull with incredible accuracy. After that, we'll get our hands dirty with the setup protocol, learn to speak the language of sleep, and finally, we'll talk about how to be a guardian for that precious signal.
All right, first things first. To get that perfectly clean data, we have to understand the one single principle that is behind every single waveform you see on that screen.
And that one principle is called derivation. I know, it sounds technical, but it's actually super simple. Every single one of those squiggly lines on an EEG readout is just the answer to a simple subtraction problem. The machine takes the electrical signal from one active electrode and subtracts the signal from a reference electrode. It's that difference, that comparison between 2 points, that creates the waveform that means something. It's all relative.
And this brings us to what is, without a doubt, the single most important rule in all of sleep medicine. If you remember one thing, let it be this. If the data on the screen looks like a jumbled mess, the problem isn't the patient's brain. It's almost always the connection. The very first thing you do is fix the physical connection at the electrode itself. You do not try to interpret bad data. It's the ultimate case of garbage in, garbage out. Okay, so if those little electrodes are that important, it stands to reason that where you put them has to be absolutely perfect. And this isn't guesswork at all. It's a precise, repeatable science, basically cartography of the human head.
So here's the secret to getting it right every time. It's not just what you measure, but where you measure from. And you're not measuring from the skin, right? Because skin can shift and stretch. No, you're measuring from the skull itself. Techs use these fixed, bony landmarks that don't move, like the nation right at the bridge of your nose and the inion, that little bump at the back of your skull. These are the anchors, and from those anchors, they use the International 10-20 system. It's a brilliant method that uses percentages of the skull's total circumference. This means it creates a perfectly proportional and repeatable grid on any head, big or small. This is what ensures that a study done in Boston can be perfectly compared to one done in Tokyo. Now, out of all the points on this map, the absolute king, the most crucial landmark, is CRISI. That's the very top center point of the head. It's so critical that techs are trained to find it twice, using 2 different measurements. And here's the kicker. If their 2 marks for CRISI don't land in the exact same spot, they don't just split the difference and call it good. Nope, they have to start all of their measurements over from scratch. That's the level of precision we are talking about here. It has to be perfect.
So once that map is all drawn out, the names for the electrode sites might look like just a jumble of letters and numbers, but there's a beautifully simple logic to it. The letter tells you the region of the brain it's sitting over. So F is for frontal, O is for occipital. Easy enough. And the number tells you which side of the head it's on. Odd numbers are for the left hemisphere, and even numbers are for the right. So if you see C3, you instantly know. Central lobe, left side. F4, frontal lobe, right side. It's this elegant universal code that every single tech understands.
So we've got our map, we've got our coordinates. Now it's time to put all that theory into practice. Let's walk through the meticulous, hands-on protocol that turns that map on the head into a working, high-fidelity diagnostic tool. This is like a 5-step ritual that every tech follows religiously. First up, skin prep. You have to gently clean the site to get rid of any dead skin or oils to make sure you get a great electrical connection. Then, you place the electrodes, starting with the midline ones first to keep everything perfectly symmetrical. Third, and this is a big one, you do an impedance check. Think of impedance as electrical resistance. We want a superhighway for the brain's tiny signals, not a bumpy dirt road. The goal is to get a reading below 5 kiloohms, which tells us we have a rock-solid connection. Fourth is just smart cable management, bundling the wires so they don't swing around and create false signals. And finally, you do biocalibrations. This is where you ask the patient to blink or clench their jaw or look left and right, just to confirm that every single sensor is picking up exactly what it's supposed to. It's like a sound check for the brain.
And that brings us to this crucial point, this absolute mantra of the profession. There is no "we'll fix it later." The entire success of the 8-hour study is built right here, in this room, before the lights even go out. If that impedance check comes back high, showing a bad connection, you don't just cross your fingers and hope it gets better. You take that electrode off, you re-prep the site, and you fix it. Right then, right there, every single time.
Okay, so we have a clean signal. It's strong. Now we can finally start to figure out what it all means. And I want you to think of this next part as if we're learning the vocabulary and the grammar of a brand new language, the language of sleep.
These different waveforms? These are our vocabulary words. Each one has a very distinct shape and tells a specific part of the story. For example, you see those big, slow rolling delta waves? That is the unmistakable signature of deep, restorative sleep. That's the stage where your body does most of its physical healing and memory consolidation. And what about those brief, beautiful little bursts called sleep spindles? They're a classic hallmark of stage 2 sleep, and we think they help filter out background noise to keep you asleep. A good tech learns to spot these words in an instant.
So if the waveforms are the words, then this decision tree is the grammar. It's a set of rules you use to put the words together into a meaningful sentence. Techs analyze the data in 30-second chunks, which are called epochs. And for every single epoch, they follow this strict, logical decision tree that takes all the guesswork out of it. It's a simple set of questions. Is there an alpha rhythm present? Yes? Okay, the patient is awake. No? Okay, next question. Is there a sleep spindle or a K-complex? Yes? Bam, that's stage 2 sleep. This logic tree turns sleep staging from an art into a repeatable science.
But here's the thing. The technologist's job doesn't end when the patient falls asleep. Oh no. All night long, they become the guardian of that signal, constantly on the lookout for imposters that can mess up the data. And those imposters have a name. They're called artifacts. An artifact is basically any electrical signal that did not come from the brain. It's noise. It could be muscle tension from a tiny jaw clench. It could be the electrical signal from the patient's own heartbeat bleeding into the EEG, or it could even be something as simple as sweat causing the signal to slowly drift. The tech's job is to identify these intruders and make sure they aren't mistaken for actual brain activity.
And when a signal does go bad in the middle of the night, techs don't panic. They have a protocol for that too. It's called the Golden Troubleshooting Order, and it works from the biggest potential problem down to the smallest. First, you check the master reference electrodes behind the ears. Why? Because so many other channels rely on them. A bad reference can corrupt half the study at once. It's like checking the main fuse box before you check a single light bulb. If the references are okay, then you move on and check the impedance of that one specific bad electrode. If it's high, well, you know the drill. You have to go in and re-prep the site. And if an artifact just can't be fixed, the final, crucial step is to document it so the doctor who scores the study knows exactly what they're looking at.
So when we put it all together, you can see this is so much more than just a list of rules. It's really a philosophy. It's about replacing guesswork with precise measurement. It's about putting the physical connection above all else. It's about building the entire study on a solid foundation of perfect references. You trust the logical patterns in the data, and you meticulously document everything. This is, in essence, the creed of a great sleep technologist. Because in the end, everything we've talked about comes back to the human element. This isn't just about fancy machines and software. It's about expertise. All of this precision, all of these protocols, they're all designed to empower a skilled, knowledgeable technologist. Because at the end of the day, a confident tech, one who trusts their training and their meticulous setup, is the person who produces the clean, accurate data that can genuinely, truly change a patient's life for the better.